Alright, so we're doing the point line and plane postulate notes. And this is the first time that we will have been introduced to what a postulate is. Today we're going to talk specifically about postulates. But here in the beginning I want to tell you the difference in these different types of rules, basically, that we follow when we're talking about geometry. Geometry is a logic-based subject, meaning that all of the things that we do have to be based in true statements, things that are always true without exception. And we have different types of those statements. We have definitions, which we're all familiar with, postulates, also called axioms, theorems, and corollaries. And you'll find that there are a vast number of theorems, fewer postulates, and fewer corollaries that we will work with in our textbook. If you want to see all of the possible postulates or theorems that we're going to be dealing with throughout the year, you can find the postulates listed on page 827, and you can find the theorems starting on page 828. They go on for about 5 pages, so there's more theorems than what we have of postulates. So let's talk about what each of these are. A postulate is a rule that is accepted without proof. Usually these are statements that are easily understood. They're not something that we need explained to us. A theorem is a true statement that follows as a result of other true statements. So it's as if one true statement leads us to another thought, which leads us to another thought, which may turn into a theorem. Now, all of these things that we're going to be studying are things that were established as theorems or postulates or corollaries many, many, many years ago. It all goes back to a guy by the name of Euclid, which was a Greek mathematician. If you want to look him up or you want more information, I can give you that later. And then lastly, we have a corollary. And a corollary is a statement that can be proved easily using a theorem or a definition. Those are things that, because there are fewer of them, they're usually based in theorems. The ones that we will use will be based in theorems, typically. And to be honest, I don't, off the top of my head, remember all but one of them right now. All right, so point, line, and plane postulates. We're going to talk about 7 different postulates. These are all going to be 7 statements that are easily understood. Some of them you will already know, even though you don't realize that you already know them. For a few of them anyway, you're probably going to have that, well, yeah, I know that already, kind of, why do we have to write this down, kind of thought. But that's what postulates should be, things that are simpler to understand. So our first one, through any 2 points, there exists exactly one line. So that's one of them. The second, a line contains at least 2 points. Now from algebra, you know that a line contains infinitely many points. Here we know that we have to have at least 2 of them. And the third one, if 2 lines intersect, then their intersection is exactly 1 point. Okay, so I'm going to leave a little space because I want you to kind of see a difference that's going to pop up here for just a minute. Moving on. The fourth, through any 3 non-collinear points. And remember, those are points that don't lie on the same line. Through any 3 non-collinear points, there exists exactly 1 plane. So 3 non-collinear points make a plane. Our 5th one. A plane contains at least 3 non-collinear points. Nothing too shocking there. Kind of a rewording of that last one. And our 6th. If 2 planes intersect, then their intersection is exactly one line. And you'll remember in class when we talked about intersections of planes yesterday that we kind of likened it to imagining the floor as one plane and the wall as one plane, and where the floor and the wall meet, that corner that it creates all along the bottom of that wall, that line that it creates where we would put a piece of baseboard, that's what this is illustrating. If two planes intersect, like the floor and the wall, then their intersection is exactly one line. Now, if you compare the first three, the ones about points and lines, with the next three, points and planes, you'll see that they're worded very similarly. That just kind of helps us kind of remember them a little more simply, but the structure is basically the same. And then this last one, the seventh one that we're going to talk about, it's kind of a combination of points, lines, and planes. If 2 points lie in a plane, then the line containing them lies in the plane. Well, what the heck does that mean? It means that if I were to take a piece of paper, which becomes my plane, and I were to draw 2 points on it, and then I continued to draw a line through those 2 points, that I could guarantee that because the 2 points were on the paper, then the line would have to be on the paper as well. There's no way for the points to be on the paper and the line to like hover above the paper, for example. That if the 2 points are on the plane, then the line that goes through them or contains them will also be on that plane. So these are our 7 postulates that we're going to be looking at today. Now, you'll recall that I said geometry, and in this, what we're getting into with geometry, deals with being able to verify something or to prove that it is true, to have something to back up a statement with. I know this is true because, etc. So what we're going to be looking at with these postulates, and you'll find these on the back of the page, you'll find that we have statements related to this diagram that's giving over here on the left. And we're asked to state the postulate that verifies each statement. In other words, find one of those postulates that shows, like number 1, is true. We know that it ought to be, but which postulate says it has to be? So as I look at number 1, the points x, y, and z lie in a plane. So the first thing I notice in that statement is talking about 3 points, x, y, and z, and that the statement ends with something about a plane. So at this point, I would go back to my postulates, and I would look for one that has something about 3 points and something ending with a plane. Now you'll find that there are 2 of them that might work. We've got this one that says something about 3 non-collinear points. There exists exactly one plane. And we have this one, a plane contains at least 3 non-collinear points. Now the trick is to look at the order of the words. In the statement that we're given in number 1, it says the points x, y, and z. So it starts with something about the 3 points, and then continues on stating that those points x, y, and z lie in a plane. So the statement ends with something about a plane. So here I'm looking for the postulate that starts with something about the 3 points and ends with something about the plane, which would be this first one. So that becomes the one here in red is the one that I want to fill in then on the back for number 1. So here for number 1, we're going to fill in through any 3 non-collinear points. There exists exactly one plane. Starts with something about the points, ends with something about a plane. Now what I would like for you to do is try numbers 2, 3, and 4. So pause the video, try those 3, and then when you think you have them finished, come back and you can check your solutions. Alright, so on number 2, this one's going to start with something about 2 points and end with something about a line. So here, the correct one, through any 2 points, there exists exactly one line, very similar to the number 1. For number 3, starts with a statement about two planes intersecting and ends with something about a line. So here, if two planes intersect, then their intersection is exactly one line. And the last one, if 2 points lie in a plane, so we've got 2 points lie in a plane, and then something about the line lies in the plane. So in this case, if 2 points lie in a plane, then the line containing them lies in the plane. It's a word association, kind of matching the words in the statement to the words in the postulate. Now the last 4 that are on this page, numbers 5 through 8, are just there for you to use for further practice if you feel you need it. We will have a quiz over the notes from points, lines, and planes yesterday, and today's points, lines, and planes postulates. We'll have that quiz in a couple of days in class, and you'll find that date either on the board or you'll be hearing me saying it in class. You can use these 4 problems as practice for that, and then you're welcome to come look at my answer key or ask me to look over them to see if you got them right.